Good morning, learners! Welcome to the newest episode of our lecture series in Science 8. Tara! Get your modules, pen and paper, and let's start learning.
In this episode, we are going to discuss various concepts related to atoms and the subatomic particles. Before we proceed to our lesson, always follow the minimum health standard, especially when in public places to prevent the further spread of the COVID-19 virus. Maintain physical distancing, wear your face mask properly, sanitize frequently, and get vaccinated. In today's lesson, we are going to describe the electron, proton, and neutron of an atom. Identify the atomic number and mass number of a given element, and cite updates and recent studies on atoms and subatomic particles.
Do you have any idea of what atoms and the subatomic particles are? Well, let's listen to this song to know each one of them.
Atoms are the basic building blocks of all matter. They're extremely small, make up everything in our universe. Stars, these bananas, our entire body, all made of tiny atoms fit together differently. Atoms are made up of three particles called electrons, protons, and neutrons. Electrons are the smallest, their charge is negative, spinning really fast all around the nucleus. The proton's positive and located in the center, forming the nucleus with neutrons that have no charge at all. When particles are mass different, makes various elements. One proton, one electron, the simplest atom's hydrogen. Every element has its own atomic number. Tells us how many protons located in its center. Less protons means less mass, like hydrogen, that's a gas. It's less dense in the air, one proton in the nucleus. Because protons have a strong positive charge, push each other away, bubble back with a strong nuclear force. Balance makes atoms possible. Everything in the universe, different atoms come together, are known as molecules.
Did you enjoy the song? Now, let us answer the following questions based on the information stated in the song. First, what are atoms? Atoms are the basic units of matter and the defining structure of elements, which means everything you see around you, from the stars, stones, animals, plants, and including your own body, is made up of atoms. Second, what are the three subatomic particles? The three subatomic particles that make up an atom are proton, neutron, and electron. Proton is a positively charged subatomic particle with a mass of 1.672 times 10 raised to negative 24 grams. It is found at the center of an atom called the nucleus. Meanwhile, the neutron is an uncharged subatomic particle with a mass of 1.675 times 10 raised to negative 24 grams. It is also located at the nucleus of an atom. Together with the proton, they contribute to the mass of an atom. And finally, the electron is a negatively charged subatomic particle with a mass of 9.11 times 10 raised to negative 28 grams. It surrounds the nucleus of an atom. Remember, proton carries a positive charge and neutron is uncharged. Together, they are found at the nucleus of an atom. Meanwhile, electron carries a negative charge and surrounds the nucleus of an atom.
Now, you can already accomplish the activities in your learning activity sheet number 5. At this point, let us discuss two of the unique properties of each atom, the atomic number and atomic mass.
When we say atomic number, it is equal to the number of protons found in the nucleus of an atom. In other words, the number of protons in an atom corresponds to its atomic number. Why? Because the number of protons and the atomic number of an atom are the same. Hence, a hydrogen atom which has one proton has an atomic number of 1 and vice versa. A sodium atom which has an atomic number of 11 has 11 protons in its nucleus. What about the number of protons of a barium atom which has an atomic number of 56? Its number of protons is also 56. Oh, Benton is here. And when we see Benton, we don't say it's hero time. Instead, we say it's trivia time. Did you know that in a neutral atom, the number of protons and electrons are equal? Since the number of protons is the same with the atomic number of an atom, we can say that the number of electrons, protons, and the atomic number of an atom are the same. Hence, an iodium atom with an atomic number of 41 possesses 41 protons and 41 electrons. And the nickel atom with 28 protons has also 28 electrons and has an atomic number of 28. Now, let us move on to atomic mass. When we say atomic mass, it is the total number of protons and neutrons in an atom's nucleus. Hence, a silver atom which possesses 61 neutrons and 47 protons has an atomic mass of 108. 61 plus 47 is 108. And a cobalt atom which has 32 neutrons and 27 protons has an atomic mass of 59. 27 plus 32 is equal to 59.
Now that we know that an electron and proton of a given atom are the same, how we can find both given the atomic mass of an atom?
To determine the number of proton or electron of an atom, subtract the number of neutron from its atomic mass. Hence, a lithium atom whose atomic mass is 7 and has 4 neutrons, its protons and electrons are equal to 3. 7 minus 4 is 3. And a potassium atom which has an atomic mass of 39 and has 20 neutrons also has 19 protons and electrons. 39 minus 20 is 19. What if the number of proton or electron and the atomic mass is known instead? How can we determine the number of neutrons of an atom? To determine the number of neutrons, subtract the number of protons or electrons from the atomic mass of a given atom. Hence, a magnesium atom whose atomic mass is 27 and has 13 protons and electrons has a 14 neutrons. 27 minus 13 is equal to 14. And an indium atom whose atomic mass is 115 and has 49 protons and electrons has 66 neutrons. 115 minus 49 is equal to 66. With this, you can now accomplish the different activities in your learning activity sheet number 6. Oh, it's another trivia time! Apart from the discovery of protons, electrons, and neutrons, smaller subparticles than those earlier have been identified. These include quarks, gluons, which are the building blocks of protons and neutrons, which in turn are the building blocks of atomic nuclei. Hence, this further disproved the idea that the atoms are indivisible. Have you learned from our discussion? Before we end our lesson, kindly answer the supplementary assessment sheet number 3 given to you. Also, write a 3-sentence reflection about the importance of small things like atoms in our lives. Write your answer on the comment section of this particular video lesson thread. You can do it, my dear learners. Please also keep in mind to respect everyone's views, opinions, and insights in our Facebook group.
Heads up, learners! You just completed your module in science this week. Keep being inspired and see you in the next video lesson.